Oh boy.
My dad's like, what are you supposed to be? It's like, yeah. Shit, I love the big deal. I have this share set. I do like it's a cat. Yeah. Yeah, I saw it like right. Yeah, because I have.
Boy, that's good. Some good handwriting right there, huh? That's just, I've been practicing that with my pen. Right. Oh boy. Oh no.
In the Halloween costume.
Yeah, so I got some examples for you. So hopefully you're cooking through yesterday's assignment. Like I think I said yesterday, you didn't have to get it done, but you should probably within the next 4 days. But then I'm going to add some more on today. Today's will be on Delta Math. So I have 6 examples for you. Each one should take a few minutes. So obviously, you know, from the title, what's different today is that now there's variables on both the left and the right hand side. So here we go. So let's say we had the absolute value of 4x minus 4. Remember to make those absolute value bars noticeably taller than your numbers so that they don't look like ones. Every problem in the new assignment today will have variables on. It may not start that way. You may have to move things around, but when we get to the business part of the problem, then you'll always have an absolute value equals a variable value. And that's why today gets its own lesson. So any thoughts on maybe what we could do first? Something about the 4, right? That like we just know our instincts tell us that this -4 just can't be here. Like we know this from prior work. And the difference is today, when we move the 4 across, it can't join with the 5x. So we're not just going to get a number. That's why today is different from yesterday. So we wind up with the absolute value of 4x minus 4, but it's equal to 5x plus 4. Good so far? I mean, I really haven't done much, but everyone okay? So it's at this point that we really embrace the idea, what we learned yesterday about how we split this into 2 equations. The fact of the matter is this: the stuff that's inside the absolute value either has to equal that or the negative of that. And that is what we learned yesterday. When we learned it yesterday, we didn't have x's on the right-hand side, but the idea is still the same. The stuff inside the absolute value either equals 5x plus 4 or equals the opposite of 5x plus 4. That just doesn't change. Regardless of how different looking it is, the idea is still the same. So we're going to make 2 separate equations here. One of them is going to say that the stuff inside, 4x minus 4, maybe it just equals 5x plus 4. The other equation is going to say stuff inside 4x minus 4, maybe you equal negative 5x minus 4. And I wrote what I wrote previously because I wanted you to understand that there's a negative distribution happening here. So up here in the right-hand corner of the TV, you can see that the opposite of a quantity means you have to take the opposite of everybody in the quantity. So the opposite of 5x is negative 5x, and then the opposite of a plus 4 is a minus 4. If you're not lost, then you're going to be just fine. Like the rest of this is pretty smooth sailing. So now we just have to solve the purple equation and solve the green equation. They're just a little bit harder. Yesterday's equations that you had to solve were pretty 6th gradey, 7th gradey, like at the end. These are a little bit more high schooly. I'm still not difficult. So let's talk about the purple one first. What would you guys do to solve purple guy? I wouldn't add 5x to 4x because they're on different sides. I would move the 5x though by subtracting it across, which brings me on the left-hand side now to negative 1x. Right? Remember, you can't just combine them when they're on opposite sides. You know, if you'd never solved an equation before, I would have shown this. You know, if we were in an Algebra 1 class and pretty brand new at this, then I would show my work like that. But we know what we're doing. And then also, I have to move I'll use, I guess, yellow for this. We have to then take this -4 and move it across to this side, right? That's just algebra equation solving 101. Variables go one way, numbers go the other way. And which way you put them all doesn't matter as long as you don't put them on the same side. So if I add 4 to both sides, I get 8. So I can now say that negative x equals positive 8. So what does x equal? Perfect. So there's one of our solutions. X equals negative 8. Okay. Now we're going to go solve the green equation. And when we're done with that, we're not done. This is going to be a big difference between yesterday and today, is that the solutions are sometimes not actually solutions. And I'll show you what I mean. So yesterday it never happened, so I never brought it up. It can't happen on problems like yesterday. But today it starts with the variables on the opposite side. Strange things can happen. So let's go solve green guy. And we'll just kind of embrace the same thinking. I'm going to take the negative 5x and I'm going to chuck it over there with its homie to make 9x because I added it, of course. And then I'm going to take the -4 and add it across there with its buddy, and negative 4 plus 4 equals 0. So far, so good. And then we divide both sides by 9, and we now make the claim that x equals 0. At this point yesterday, you would have stopped and just said, those are my answers. But today, you have to start checking your solutions for reasons you'll understand, I think, in about a minute. So I'm going to take these two answers. They're not answers right now. That we have to switch my verbiage and call them candidates, because now they don't necessarily. Sometimes they'll both work. Sometimes neither of them will work, and sometimes one of them will work. It is what it is. So the original problem, I'm going to recopy it just so I can have it on my screen, said the absolute value of 4x minus 4 minus 4 equals 5x. So what I'm going to do is I'm going to one at a time, I'm going to take these numbers and check them. I told you yesterday that it was like, do it or don't do it. That is gone now. There's no more. It's up to you. You need to check your answers now. So we're going to take -8 and we're going to put it right here. And we're going to put it right here. And we're going to see if this equation that we get is true or a load of baloney. So if you put -8 in the first arrow right here, what's 4 times -8? -32. So this will be the absolute value of -32 minus 4. And what's -32 minus 4? -36. And what's the absolute value of -36? So this left side now says 36 minus 4. And what does that equal? 32. And you can clearly, I hope clearly see that if we follow the longer purple arrow and we put -8 in the right-hand side, what's 5 times -8? And 32 clearly does not equal -40. Therefore, even though we discovered it and we didn't do anything wrong, -8 is not an actual solution. You're going to come to hear this word a lot more. It's called an extraneous solution. You don't have to write that down like when you do the problems, but I do need you to know that when I use that word, that's what I mean. Solutions that we find algebraically aren't always actually solutions. And it's not the math gods pranking us. It's just that when you start playing around with exponents and absolute values, strange things happen to numbers. And absolute values turn things positive and exponents turn negative numbers positive sometimes. And so that's why we have to take into account that some strange things could happen. It's not just because it's Halloween, things happen. So now our job is to see if the other candidate can survive. So this time we're going to take the number 0. And again, we're just going to plug it in. So we're going to take 0 and we're going to plug it in here. and here. And we're going to see if the equation that results is, again, good or bad. So if you go into the longer green arrow and you put 0 right at the tip of that arrow, what's 4 times 0? And what's 0 minus 4? -4. And what's the absolute value of -4? And what is 4 minus 4? So we have 0 equals. If you put 0 into the shorter green arrow, what is 5 times 0? And 0 does equal 0. So at the end of the day, when someone says, what is the answer to this problem? The answer is x equals 0. Done. So
Can you go to the office, please?
there, no one will ever even know. There'll be like this little jumpy click, but no one will ever know the dad joke that I made. So that is how you solve an absolute value equation when there are variables on both sides. You proceed. It's a lot more difficult than yesterday, you would agree. Still not really hard, but comparatively speaking, like, wow, that's a lot more work. So let's do another one. The absolute value of 5x minus 6 plus 3 equals 4x. What do we do first? Subtract that 3. So we get to the crossroads here. We say the absolute value of stuff that I still don't care about equals 4x minus 3. And this is always that point where, and by the way, today there is no looking at it and saying no solution. Like that yesterday, if the right-hand side just said -3, you of course would stop right there and say no solution, done. This one, the crossroads is, there's really not even a choice. You just go and write two equations. And maybe they'll both turn out good, maybe who knows, but we do have to write them both. So what's one of the equations going to say that we write? Just like that. You essentially make an exact copy with the absolute value signs gone. And then what is the other equation going to say? Nice job. So remember, when we negative the right-hand side, we're negativing. Sorry, that's not a real word, I don't think. I think it's negating. We're negating both terms. 4x changes, -3 changes, and there you go. And then we just rock some basic algebra 1 here for a couple minutes or so. So on the purple equation, I would move the 4x to the left. By subtracting it, giving me 1x, I would add the 6 to the other side, giving me +3. That was easy. On the red equation, I would add 4x across to the left, giving me 9x, and then I would add 6 to the right, giving me 3 plus 6, which is 9, and I would divide and get x equals 1. So we have our candidates, and we're going to plug them back up in. By the way, you can plug your answers into the original problem, or if for some reason you like it better, you can also plug them into this problem. As long as you plug them in someplace before the split took place, while the absolute values are still on, then it'll give you the same results. Some people like the second equation better just because it feels more like structurally sound, maybe like everybody's where they're supposed to be. Which one do you guys want to do, the top one or the bottom one? First or second? Second? I just heard that first, so we'll go with the second. So you can do these pretty mentally, assuming that your basic skills are tolerably okay. So we're just going to take this equation, just so everyone's clear. I'm using the one in the purple box. You could have easily used the one above it. It's okay. And I'm just going to change the numbers there and there into 3. And feel free. You don't have to show a lot of work on this. Like this isn't, pre-algebra or something. So where the first arrow is, what's 5 times 3? What's 15 minus 6? 15 minus 6. I think it's 9. I just thought I heard a 5. Sorry, okay, I thought I heard a 5. Good, so 9 it is. So on this one, we have 9 equals, because the absolute value of 9 is 9. And then if you put 3 on the right-hand side, what's 4 times 3? 12 minus 3. 9 does equal 9. So I can go ahead and box up that answer and say, I have checked you and you, sir, are just fine. Okay, now we got to go do it also with a 1. And this time we'll just put the 1 where the red arrows now are up here. Just rinse and repeat. So what is 5 times 1? What is 5 minus 6? -1. And what is the absolute value of -1? So the left side equals 1. And then if you put 1 in the right-hand side, what's 4 times 1? And what's 4 minus 3? 1. So this time we have 2 solutions. So in a case like this, they both worked. And that, like I said, it's just kind of, it is what it is. Sometimes they'll both, sometimes one, and sometimes, as you'll see here in a bit, neither of them also could possibly work, in which case you just have no solution. So let's do another. The absolute value of 2x minus 3 equals x. So you, of course, have no prep work to do. You've got the absolute value by itself. So you're ready. While I pour some coffee, why don't you guys write the 2 equations that you get from Splitsville? And then I'll catch up to you here in 10 seconds. So one of the equations that you wrote should say that stuff inside equals normal x. The other equation should say stuff inside equals the opposite of x, like this. Right? To solve the purple equation, I would do a couple things. And again, because this is not an 8th grade class, I would just do this all mentally. I would subtract the x across to both sides to give me 1x. I would add the 3 across, and I would get 3. The next one I will just show work as a courtesy to you or whoever watches the video later. I would add x to both sides, giving me 3x. I would add 3 back across, giving me 3, and then I would divide by 3 to get x equals 1. Remember, those are not answers. Those are candidates. We just want to know if they're legit. And we do that by just sending them through, test them, run them through. And so let's try the 3 first. If you put 3 where the purple arrows are, what is 2 times 3? 6 minus 3. The absolute value of 3 is 3. And so we can say that the left side equals 3. The right side, if you put in 3, duh, you just get 3. I think we can safely say that 3 works just fine. Okay. Now we're going to send the red number, the 1, through the gauntlet, and we're going to put 1 where the red arrows are. And so what is 2 times 1? 2 minus 3, the absolute value of -1. So the left side equals 1, and the right side obviously equals 1. So 2 problems in a row, we have figured out that we have 2 solutions. So when you're doing this in Delta Math, you remember that in Delta, when you want to do 2 answers, you have to hit additional answer. There's a little plus button that says that. If you don't know where that is, just ask, and then you get a second answer box and you type it in. So let's go example 4. Does anyone want to guess what's going to happen on this one? Say again. I think, if I remember correctly, that is why I got this one on here. So let's go take this for a spin. And again, I just don't think, I know some people endeavor to find shortcuts. I don't know why I could just look at this and say that it has no solution. But if I recall correctly from when I wrote this, it just didn't work. And I don't really have a sense as to why. It is what it is. So it's ready to go. So one of the equations is going to say stuff inside. Maybe you equal exactly what I see. The other equation says stuff inside. Maybe you equal the opposite of what I see. And this just, you'll if you're a mathy person at all, you'll understand why the answers don't work. It's just hard to understand why we would know that from the beginning. That's all. So purple equation, I would subtract the 3x across, giving me 2x. I would subtract the 8 across, giving me -8. And I would make the claim that x maybe equals -4. On the red equation, I would add the 3x across, giving me 8x. I would subtract the 8 back across, giving me -8. And I would see that x maybe equals -1. You can see, if you were paying attention yesterday, why already we know both of these answers won't work. Because let's follow purple arrows first. Actually, I'm not even interested in anything other than this purple arrow. If you put a negative number there, what will this right side equal? Negative something, right? And it doesn't even honestly matter. You could put -1, -2.6, -50. At the end of the day, if you put a negative number into that purple circle, you get absolute value of I don't care equals a negative. And we learned yesterday that that's not possible, correct? So you can see quite simply that in both of these situations, when you put a negative number into this, it doesn't matter. What I'm trying to say is that this part doesn't matter, right? It just doesn't matter because absolute value cannot in a million years equal a negative. Therefore, this one cannot work. This one cannot work. So we would say that this problem has no solution. Okay. So I've got 2 more examples on my note card. I just wanted to, it's really nothing new now. You've learned what I want you to learn. I just want you to see that problems can look a little bit differently from the get-go. So let's do a couple more. So on this one, we're going to have 1 plus the absolute value of 2x plus 7 minus x equals 0. And I'll say it again, try to make your absolute values look taller, please, for both my benefit and yours, but, you know, more for yours. What's our first move?
-1.
Yeah, and we can go ahead. Let's just do 2 things at once here. We agree that both the x and the 1 are out of place. So why don't we just chuck them both up and over the wall? No sense in making this take longer than it needs to. So we are going to isolate the absolute value of 2x plus 7. And what is the right side going to say?
X minus 1.
No,
X minus 1.
positive x minus 1. Because when we move things, they change, right? We okay? And now we're right back to where we were before. So let's write our 2 equations. One of the equations says, hey, stuff inside, maybe you equal exactly what I see. The other equation says, hey, stuff inside, maybe you equal the entire opposite of what I see. And what would be the opposite of the right side? Nice, negative x plus 1. And now we're just, you know, business as usual. We're going to solve the purple equation. I'm going to move the x over here, giving me 1x. I'm going to move the 7 over here, giving me -8. Okay, and on the red equation, I'm going to move the x over here, giving me 3x. I'm going to move the 7 over here, giving me 1 minus 7, -6. And I'm going to divide and get x equals -2. And again, the separating factor today is that I don't know if those are actually answers or not. Starting today, extraneous solutions are fully in play. So we go back and I feel like this is my preference, but I tend to like to use the equation that just feels cleaner. I've always done it that way. So you're welcome if you want, as I do this, to use the top one. I just like the bottom one better. It just feels better to me. So I'm going to take where the purple arrows are pointing, and I'm going to change both of those x's into my first candidate, -8. What is 2 times -8? It is not 16. It is -16. And what is -16 plus 7? -9. And what's the absolute value of -9? So the left side is 9. And then I'm going to put an equal sign. And now I'm going to wait. On the right-hand side, what's -8 minus 1? -9 is not the same as +9, right? The right side doesn't get absolute value. Like, it is what it is. And since 9 doesn't equal -9, we can say, hey, thank you for your participation, but -8, you are no good. You don't work. Okay. Then we're going to do the same thing, only now we're going to put the number -2 where the red arrows are pointing. And can you already see that this is not going to work? I mean, you have to be able to do fourth grade arithmetic. Like if you can't right here in this red circle, if you can't do -2 minus 1, you're probably in some pretty serious trouble, right? What is -2 minus 1? -3. And the absolute value of whatever's inside of here, I don't care. It's never going to equal -3. It is not possible. Therefore, this answer does not work. And we say no solution. Got it? One more. Last. The absolute value of x plus 3 minus 5x equals -9. What do we do first? Absolutely. Just add 5x. You had it right the first time. It was a gorgeous thing to say. So we have the absolute value of x plus 3 right where we want it, right? Isolated. And the right side is going to equal a now positive 5x and a still -9. Isolation complete. Remember, there is no decision making at this point in time. Yesterday, we looked and we made an assessment. Today, we just brainlessly, robotically go in and write two equations because we just don't know what's going to happen. So one of the equations will state that, hey, stuff inside the absolute value, maybe you just equal what I see. And then the other equation says, hey, stuff inside the absolute value, maybe you equal the dead opposite of what I see. And what's the opposite of the right side? Perfect. -5x plus 9. And then you solve the equations. On the purple equation, if I move the 5x to the left, I get -4 of those. If I move the 3 to the right, I get -12. If I divide, I get a candidate x equals maybe 3. We don't know yet. We'll find out in a bit. On the right-hand side, if I solve the red guy, if I move the -5x over here, I get 6x. If I move the 3 to the other side, I get 9 minus 3 is 6. And I have another candidate. Just one by one, I just check my answers. And so where these little arrows are going to be right there and right there, I just change them into 3. And I wonder, do you work? Let's find out. In the first purple arrow, what's 3 plus 3? 6. And what's the absolute value of 6? 6. So we're now just in a holding pattern, waiting to see if the right side cooperates. If you put a 3 where the second purple arrow is, what's 5 times 3? 15 minus 9. 6. Therefore, 6 does equal 6. The left side and the right side agree with each other. So 3 gets a box. 3 is good to go. And then we're going to change these little arrows up here to red now because I'm colored. I'm a big color coder. I'm sure you have long since figured that out. So if you go where the red arrows are, we change them into ones. What is 1 plus 3? What's the absolute value of 4? So I'm in a holding pattern now, just waiting to see what happens. On the right-hand side, if you replace this x, what's 5 times 1? What is 5 minus 9? 4 does not equal -4. Therefore, this one is no good. And it has one solution. His name is x equals 3. So throughout those examples, I tried to show you it's just a mixed bag. Sometimes you're going to get 2 answers. Sometimes you're going to get 1. Sometimes you're going to get none. And that is what it is. So your next assignment is on Delta Math. So today, for the rest of this 15-ish minutes, you can work on the one from yesterday if you're still rocking that, or you can hop in and work on the new one. It's up to you. I will leave this paused if you have any questions.